Hi everyone, it's Coach Fred here, and today I'm going to be going over inverses part 2. So you should have watched part 1 first. So inverses part 2. And I'm looking here at two functions, the cubic function and the cubed root function. And I want to just make sure we understand what happens to each function and why they're inverses again. Okay, so if I plug in the -2, -1, 0, 1, and 2 into the cubic function, I'm going to get -8, -1, 0, 1, and 8. All right, so if I take I let these be our x's, if I let f of x be our x's, then I take the cubed root of each of these x's, so of these, I'm going to get -2, -1, 0, 1, and 2. So you can see that inverses bring you back to the x. When you plug f of x into g of x, you should get x. And that's where I wanted to start today. I wanted you to see a visual, a numerical representation of what was happening. Okay, so now I want to be on my notes for 5.6. And we're going to again be talking about functions and their inverses. Okay, so are the following functions inverses of each other? Explain how you know. Well, yesterday's video we talked about how you write inverse equations, and you're in essence undoing it. So in this case, it's actually kind of easy to see that if you're multiplying by 4 to get there, then you're going to be dividing by 4 or multiplying by the reciprocal to work our way backwards. But there is another way, because that's a nice, easy linear function. Another way to prove that two functions are inverses is by using composition of functions. Composition of functions. Now remember, in that last example with the cubic and the cube, I took the y's of the cubic function and I plugged them into the cubed root function, and I got myself back to x. So that's what compositions do. Remember, we plug one function into the other. So we're going to find f of g of x and see if it gives us x. All right, so if f of x is 4x and g of x is 1/4 x, I'm going to find f at 1/4 of x. All right, I'm going to plug 1/4 x into f of x. That's going to give me 4 times 1/4 of x, and simplify the 4's, and I'm left with x. So I got myself back to, again, if you think about it in a table, I got myself back here. I got myself back to x by doing the composition. Now, if that's true, though, you also have to check the other way. You have to do g of f of x. So you need to plug g into f of x. So I'm going to do g at 4x. I'm going to plug it in to the 4x into the g function, so 1/4 of 4x. The 4 is simplified to the number 1, and I'm left with x. All right, so when both of the compositions, both of these functions equal x, that means that the functions are inverses of each other. All right, so we're going to test it. We're going to determine if the following functions are inverses by using composition, okay? All right, so we're going to use the composition of functions. All right, so that means I have to do f of g of x and see if it equals x. And I have to do g of f of x and see if it equals x. All right, so I'm going to do f at 2 root x. Okay, remember, that's going to get plugged into the f function wherever there's an x. So I'm going to get that plugged in right here. Okay, all right, so I'm going to do 1/4 of 2 root x in quantity squared. Okay, so that's going to give me 1/4 times 4x. 4's simplify to 1, and I'm left with x. So it does indeed, f of g of x does indeed equal x. Now I have to do it both ways and ensure that that's true. So I'm going to do g at 1/4 x squared. Okay, so that means 2 times the square root of 1/4 x squared. Okay, so the square root of 1/4 is 1/2. So 2 times 1/2. The square root of x squared is x. The 2's simplify, I get x. So these are indeed inverse functions, okay? All right, all I'm going to ask you to do is number 21 in your notes. Bring it to class tomorrow, and hopefully that explains to you another way to prove that functions are inverses of each other. Have a great day.